I'm Anil Kumar, and here is a very good question from the test paper on Introduction to Calculus. The question is, the particle travels along a straight line and its displacement in meters is given by d of t equals to minus 1.7 t cube plus 5.2 t square plus 3, where t is measured in seconds. Find the particle's rate of change at 2.2 seconds. When is the particle's rate of change minus 75.5 meters per second? Now this is a review question. I'd like you to pause the video, solve, and then look into my suggestion. Now what we need to find here is particle's rate of change at 2.2 seconds. That means instantaneous rate of change at a point. The second one is, when is the particle's rate of change minus 75.5? Now to do the second part, we should be actually solving this equation in a very general form, equating it to minus 75.5 and then finding the time. Now therefore my suggestion is we should do part B first. Once we get a general form, we can always substitute 2.2 and get the answer for part A also, right? So I hope you understand and appreciate what I'm trying to say here. So what I'm trying to say basically is that the instantaneous rate of change can be calculated for a function like this by finding 2 points very close to one another. Let's say one point is at t plus h, so dt of h minus d of t, right, divided by h, where limit of h, where limit h approaches 0. So the second point is very close. So if I find a general expression for this and equate it to minus 17.5 as rate of change, I can find time, right? So that is how we are going to approach. So let's begin by finding the instantaneous rate of change in a general form. So we are assuming 2 points. So first point is, let us say, at t itself. The other point is at dt plus h. So let's find an expression for dt of h. So we have limit h approaches 0. dt of t plus h will be, replace t with t plus h. So what do we get here is minus 1.7 t plus h whole cube plus 5.2 t plus h whole square plus 3. So this part of this is function dt plus h. Now we'll take away t dt, right? So which is this function itself, which is minus 1.7 t cube plus 5.2 t square plus 3. It is very important to use these brackets and then everything divided by h. So that's what you get. Now we can expand these, right? So let us expand and rewrite. So we have limit h approaches 0. So let's expand these terms. So it is minus 1.7 a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube. You can use Pascal's triangle also. So let's just expand this, t cube plus 3 t square h plus 3 h square t plus h cube. That is the first part, and then let's expand this one, which is 5.2 times t square plus 2 t times h plus h square plus 3. Take away minus 1.7 t cube plus 5.2 t square plus 3, right? And everything divided by h. Perfect. Once you do that, you will notice that all the terms which do not have h will cancel out. If they don't, that means you've done some mistake. So for example, 3 with 3, correct? Plus 5.2 t square when you take away, so it is plus 5.2 when you open this bracket with this t square, right? I'm not opening but just cancelling, and the first term. So when I open, I'll get minus 1.7 times t cube. So I've cancelled that. Do you see that part? Now all these terms have h in them, right? All of them, these cancelled off. So we can take h common. So I'm writing this. I'm telling you this because I want to save some space here. So we have h common. So first term is minus 1.7 times 3. Let's use calculator. So it is, I'll write 1.7 times 3 equals to 51, that means 5.1. So it is, okay, minus, sorry, minus, right? So minus 5.1 t square h plus 1.7 times 3. So 1 point, this is the same thing, right? So 3, so 5 minus 5 point, so again minus makes it minus 1.5 ht, because I have taken one of the h common, so I should not even write this h. I'm taking h common. So I'm doing two things at the same time. So we'll write this as ht minus, this is also minus times, so minus 1.7 h square, since I've taken one h common, right? And here we are left with 5.2 times 2, which is 10.4, so plus 10.4, I'm taking h common, so writing just t, plus 5.2 h square, h has been taken out. It's a good time to check now. Okay, so this is over h. Now we can say h and h could get cancelled. Is that okay? Now, so what we are given here is this expression in which we can now substitute h equals to 0. So if I do that, then I'm left with minus 5.1 t square. That's the first term. This term becomes 0. You can see, because if I substitute h 0, this will be 0, this will be 0, and this will be 0, right? So I'm left with the two terms, which is minus 5.1 t square and 10.4 t, so plus 10.4 t. Now this is the general expression, for instantaneous rate of change at any point, at any time t. To get the idea. Now we can solve both the parts, correct? So let's solve part A first, which says find the particle's rate of change at 2.2. That means we want to find rate of change at t equals to 2.2. So we just substitute 2.2 here, right? So what do we get? We get minus 5.1, 2.2 whole square plus 10.4 times 2.2. You get the idea. So let's use the calculator. So we have 10.4 times 2.2 minus 5.1 times 2.2 square, and that gives us minus 1.804, right? So that is the instantaneous rate of change. So it is distance over time, so the units will be meters per second. So that is the answer for part A. Now for part B, we have to find t when the instantaneous rate of change is minus 75.5. So here we'll write the same equation as equal to minus 75.5 equals to this equation, which is minus 5.1 t square plus 10.4 t. Do you get the idea? So that is how we are going to solve for part B now. Okay. So let's do our calculation. Bringing all terms together, we can write this as 5.1 t square minus 10.4 t minus 75.5 equals to 0. To find t, we can use the quadratic formula. So the quadratic formula will be t equals to minus of b term, which is 10.4 now, plus minus square of 10.4 minus 4 times a and c, which is 5.1 times minus 75.5, correct? Everything within the square root divided by 2 times first term, which is 5.1. So let's calculate this value. So this minus and minus makes it positive, correct? So let's find this answer. So we'll begin with the square root part and say, so minus square will be positive. So 10.4 square, minus and minus is plus, let me write plus, 4 times 5.1 times 75.7. Okay, sorry, 75.5 it is, I'm writing wrong. 75.5. So let me delete it. Okay, where is delete? Okay, so here it is. Okay, 75.5. Let's say equal to, so we get a number which is approximately 40. Since the number is bigger, we'll add 10.4, right? So we'll plus 10.4 equals to, divided by, within brackets, 2 times 5.1, bracket close, equal to. We get answer as 5, right? So do all this calculation, so we get time t equals to 5. It means that at time t equals to 5, the units are seconds, the instantaneous rate of change will be minus 75.5. So the answer for part B is t equals to 5 seconds. And for the first one, it is minus 1.8 approximately, right? 0.4 meters per second. So that is how you can answer this question, right? A lot of calculations are involved, so be careful when you do all these calculations. We were about to make a mistake right at the end. So anyway, take care, okay? Thank you and all the best.